All right, guys, today we are starting out Unit 4 with lesson number 1, which is an overall review so far of what the coordinate plane is. All right, so you all should already know everything that I'm about to explain to you, but we're just going to write it down in our notes so that we have it in one place to refer back to. So let's talk about what is the coordinate plane. So I put my definition up here. The coordinate plane is formed by the intersection of two number lines, which we call the horizontal axis and the vertical axis. Rather than referring to them each time as the horizontal or vertical axis, we identified them as the x-axis and the y-axis. So let's write down here which is which. So the x-axis is our one that is horizontal. And I drew a picture going from left to right so that you can remember it lays flat. You can also think of the horizon if you've ever seen the sun come up over the ocean or over the mountains. It is coming out of this laying flat ground or body of water, okay? Next, the y-axis is our vertical axis. The vertical axis goes up and down, and I drew an arrow to show that hopefully to remind you that it goes up and down. All right. Also, if you look over at the image on the right-hand side of your notes, I labeled where the x-axis is, right here on the right side, and I also labeled where the y-axis is up above, okay? All right, let's talk about the origin. The origin is right here, and it is the very center where the x-axis and the y-axis intersect. And I have filled that in. Also, we call that location 0, 0. It is where both the x-axis and the y-axis have a value of 0 on their own number lines. Okay? Let's look at the quadrants. I did label them already on my picture here. Okay, quadrant 1 starts right here in the upper right-hand corner, all right? And then it goes counterclockwise. So 1, 2, 3, and 4 down here, okay? So quadrants 1, 2, 3, and 4. And those are just the 4 separate regions of the coordinate plane that are separated by the x and y axes. So let's fill in that definition for quadrants. All right, and I've also drew myself a little rough sketch just to kind of help me remember as well. All right, now let's talk about what is an ordered pair. An ordered pair is a pair of numbers used to locate any point on the plane, and the order that you put them in does matter. The x-coordinate needs to come first, and the y-coordinate needs to come second. So if you just think about the alphabet, x does come before y in the alphabet, and so that can help you remember when you are plotting or identifying a point on the coordinate plane or an ordered pair, that we always go on the x-axis first and then up and down on the y-axis. And we're about to do some examples. If you need to, pause the video right here and finish filling in any of your vocabulary that you didn't quite get a chance to do. All right, for those of us that are ready to move on, we are going to locate all of the points that you see on this coordinate plane here, beginning with A. And I'm going to try to color code as I go. So here's A. All right. First of all, I'm going to identify what quadrant is that in. It is in quadrant 1. And then let's identify the ordered pair, okay? So starting at the origin, I go to the right 1, 2, 3, 4 spaces. So I'm going to put 4. And then I count up 3. And then so my y value is 3. I wrap it up in parentheses and I'm done. That's how I get my ordered pair. Why don't you try letter B? Try to identify the location of letter B. Letter B is in quadrant 3. And to get there, starting at the origin, I need to go to the left 5 places. So because I went left, I'm going to put negative. And then I'm going to go down 6. So because I went down, I will also put a negative. And then I'm going to wrap it up in parentheses. Try C and pause the video if I'm going too fast. So C is definitely in quadrant 4. And to get there, I had to go to the right 10 places. So because I went to the right, that's positive. And then I went down 4. So my ordered pair is 10, negative 4. All right, let's try to find how do we get to point D? Well, if you look up here, I see point D is resting directly on top of the y-axis. So when you're sitting on an axis, you're not in any of the quadrants. You're simply on the axis. So what that means to get to D, I will not go I will not go left or right any number of moves. It will still be 0 moves because I'm not going to move left or right. And then I'm going to count up 7 spaces. So 0, 7. Okay? At this point, I want you to try to pause the video and finish E and F on your own, and then check back with me in just a minute and see if you were able to get them correct. All right, welcome back. I did E in a teal color, and I did F in sort of a yellow color. So hopefully you can distinguish all the different colors on the graph from how I labeled them down below. All right? Hopefully we're doing pretty good with this, and we're definitely going to get some more practice with it later. For now, I'd like for you to turn your paper over, and we're going to start talking specifically about relations, okay, and identifying domain and range. All right, so we're on side 2 of our notes, and we're going to talk about what is a relation. A relation is simply a set of ordered pairs. And a set of ordered pairs looks like this, where I do see that I have these braces, if you remember this from earlier in the year. Okay, so we have sets of ordered pairs that are all grouped together with a set of braces on the outside. Okay, a set of ordered pairs can be shown as ordered pairs, a table, or a graph. Or rather, a relation can be shown as a set of ordered pairs, a table, and a graph. Okay, let's look again at our domain and range, which is on the other side of our notes, I believe. Nope, it's not. Okay, so the domain is going to be made up of the set of all the x values. So if I'm talking about these x values here in this example, x values, I'm looking at the 6, the -3, and the 0. And then I would also wrap those up in braces. The range is going to be the set of y values in a relation. And again, if I look at the example from up above, it would be 2, 4, and -1. 2, 4, and -1. Okay. For this very quick example, I just wrote them down in the same order that I saw them as. However, when we list our domain and range, we typically speaking want to put them in numerical order. All right, so let me fix this example and put them in numerical order. All right, and so I've gone ahead and fixed my examples where they are in order from smallest to biggest. Okay, let's look at our first official example down below. Okay, starting with identifying the domain and range in the first one. So I'm going to circle all the domains, 5, -7, 0, and 4. And then I'm going to list them in numerical order. So the smallest one is -7. Next is 0. Then I'm going to have 4 and 5. The range is going to be the y values. Circle all those in green, and that will be in numerical order again. So, range. All right, so I've listed both my domain and my range below my 3 representations, okay, of this relation. Now let's fill in the table. In the table, I don't want to list them in any different order. The 5 is paired up with the 2, and I want to keep them side by side. The -7 is paired up with the 1, keep them side by side. 0 is with the 3, and the 4 is with the -4. And that's how I take my set of ordered pairs and turn them into a table. Now for my graph, what I'm going to do is plot each one of the points. So my very first point is right here, 5, 2. So on the x-axis, I'm going to go over 5, and then I'm going to go up 2 and put a point right there. I want you to pause the video and practice plotting the next 3 points. All right, if you take a look at where I plotted my 4 points, you might be slightly off. I know that these graphs are a little small, but as long as you're getting pretty darn close for what you can see, then you know that you're doing it correctly. Okay, what I'd like for you to do is try number 2 on your own from start to finish, and let's see if you can correctly identify the domain, the range, fill in your table of values, and then plot the points. Pause the video and then unpause it when you're finished. All right, I found my domain and range, and then I went ahead and paused for just a minute because I do want to point out that when I list my domain and my range values, in that list, I don't include any repeated numbers. So, in our domain, we see -6, we see 1, we see 8, and then we see this 1 again. The 1 is a repeat. And so I did not list it 2 separate times when I put my domain down below. All right? But that is not true when I fill in my table of values. I will still need to include both of those ordered pairs in my table of values. So go ahead and continue working. Okay, I've completed my table of values and I've done my very best to plot my ordered pairs correctly. okay? Let's move on and look at number 3. Number 3 is a little different. In number 3, you're not going to be plotting your points on your graph. You need to pull the ordered pairs from the points on your graph in order to list what they are, okay? So let's start with the first point. I need to start at the origin and go +2 and up 4. So +2 up 4, and that was the first ordered pair that I pulled out of the graph. I want you to practice with the other 3 points and make sure that you know how to look at a graph and pull the points out of it. So pause this video while you do that. All right, so I have identified all the 4 points on my graph, and then I wrote them as a list over here, and I put them under my ordered pairs column, okay? Now what I'm going to do is identify my domain and my range and fill in my table. So go ahead and identify your domain values, identify your range values, okay? And then down below, what you're going to do is fill in your domain and your range with no repeats in numerical order from least to greatest. And that's it. Okay? If you're still struggling with this, I want you to pause the video and call Miss Brown over. I thought there was another example. Okay, so if you're still struggling, please pause the video, ask Miss Brown to help. And actually, in your notes, there is an example number 4. Why don't you do example number 4, and then I will, at the end of this video, post the solution for example 4, all right? So pause the video, try example 4. All right, here are my solutions for example number 4. Some people have asked if it matters if their ordered pairs are in a different order than mine are, or the same thing with the table of values. And the simple answer to that is no. It doesn't matter if your ordered pairs are, if you saw -5, 3 first, that's perfectly fine. And if that's the first set in your table, then that's fine as well. Okay, it doesn't matter. The only thing that does matter when it comes to order is the domain and the range need to be in numerical order from smallest to biggest. All right. Now let's go take a look at what is a function. Functions are relations, but they're special relations where each x value is paired with one and only one y value. And this is sometimes a difficult concept for students, okay? So what I tell them to do is to look at all the x values, okay? I have 6, -4, 2, and -7. Are there any repeats? The answer is no, there are no repeats. So yes, this is a function. I wish that it was just that simple, but we do need to be careful for something else. So I'm going to add an example over here on the left. All right, I have added an example to the left, which is 2, 3, 1, -5, and 2, 3. Okay? I want you to please add this example to your notes as well. And what I'm going to do is the same process. I'm going to look at all the x values, and I'm going to say, oh, okay, 2 definitely repeats. Okay, we can all agree with that. We see 2 2s. But I then want us to look at the y values. Okay, these y values are the same, which means that the entire point was repeated. Okay, If that happens, this is still a function. Okay? Well, we'll look at example 6 in a minute, but as long as they're the exact same point, then if that x matches and that the y's both match, then that's okay, and yes, it will still be a function. Okay? Let's look at an example that's not a function. So I'm going to, again, underline my x values. I see 1, -5, -8, and 1. Now, I do see a repeat. I see a 1 and a 1, so I'm going to circle the y values. Are those y values the same number? And the answer is no, they're not the same, which means that no, this is not a function. All right, so we have done an example of yes, a function, because there's no repeats. We did an example of yes, it's a function, even when the x value does repeat, because also the y value repeats. And then we looked at number 6, where the x value repeated, but the y values did not match in those repeats, so it's not a function. I'd like for you to try to complete examples 7 through 11 and tell me why they are not a function if that is your answer. So pause the video and give those 5 examples a try. All right, hopefully you came to the same conclusion that I did in examples 7 and 8. And I also want you to notice that wherever I see the problem, I'm circling it, and that's why I'm saying no. The x value -4 was paired up with a 1. Also, the x value -4 was paired up with a -9. So I circled what the problem was. Now, in example 9, some students try to say that no, this is not a function. But I just want to point out that I looked at all the x values, -2, -1, 0, 1, and 2. None of the x values repeated, which means that yes, this is a function. Please don't let these y values that are repeating bother you. Those don't matter so long as there are no repeats on the x side. All right, so these are my answers for 10 and 11 now. And number 11 was full of problems. Every single x value repeated, and not a single one of those y values were the same. So that's clearly not a function. Let's look at one other way to determine if a relation is a function or not. So we looked at a list of ordered pairs in 5 through 8, and then we looked at tables in 9, 10, and 11. There's a different, really visually simple way to determine if a relation is a function when we're looking at a graph, okay? So I am going to look at the graphs first before I define what the vertical line test is, okay? So I am going to, first of all, try to connect my points for each of these tables here. Okay, so that's that one, this one, and then this one. So I drew graphs to connect. I pretty much just connected all the points that were plotted there, okay? What I'm going to do now is I'm going to determine, do any of these graphs have spots that have vertical lines? So pause for a minute, and if you see a vertical line, I want you to circle it. And in number 13, I see a vertical line right there, okay? There's a horizontal line in number 14, which is okay. And then I see different slopes in number 12. So there's a positive slope, a negative slope, a positive steep slope, and then a positive less steep slope. But they're all positive or negative slopes, okay? It's only in 13 I have a negative, a positive, a steeper positive, and then in this area here, it becomes vertical. So that's a problem. If you ever see a vertical line on a graph, it means that no, it is not a function. All right? And let's talk about why that is. Okay, so if I list these ordered pairs out here, let me clean this off so I can see what they would be. All right. So these ordered pairs would be, the bottom one here is 2, -1, and the above point is 2, 4. If you're looking at the points, you can clearly see that the x values repeat, okay? When the x values repeat, it creates this vertical line where you've got 2 points that are sitting directly on top of one another. And that is why this vertical line test is something that we can use to quickly identify from a picture if we have a function or not. So now let's go back up and we're going to define our vertical line test. So my definition says, if a vertical line passes through the graph of a relation even one time, and that's key,